Have you ever thought about how a computer thinks? No, it doesn't dream about pizza or cartoons like we do, but it does follow rules, solve problems, and make decisions using something very powerful, the theory of computation. Sounds like a big phrase, right? Don't worry, I'm going to break it down so simply even a fifth grader can understand. Ready? Let's go. What is the theory of computation? The theory of computation is a part of computer science that helps us understand how computers solve problems, what kind of problems they can solve, and what they cannot. A famous definition says, the theory of computation is the study of what can be computed and how efficiently it can be done. Think of it like the mathematics of computer science, but instead of solving numbers, we're solving puzzles about thinking and problem solving. Let's use a fun example. Imagine you're building a robot friend. You want to teach it how to count from 1 to 10, sing a song, play a game, solve a maze, write your name. Now ask yourself, can the robot learn all these tasks? Can it solve any puzzle you give it? That's exactly what theory of computation helps us figure out. Which problems the robot or computer can solve, which problems it can't solve no matter how powerful it is, and what's the best, fastest way to solve those problems. The 3 pillars of theory of computation. Let's meet the 3 superhero parts of this subject. 1. Automata theory. This is like building tiny machines, not real ones, just in your mind, that read and understand input, like words, numbers, or codes. For example, you make a machine that only says yes if a word ends with the letter A. If not, it says no. That's automata at work. These machines help us design programs and even help with spell check in your apps. 2. Formal languages. A computer doesn't speak English or Urdu. It speaks using symbols and patterns. So, formal languages are ways to write rules that computers understand. They help us teach the computer what to do. It's like making a secret code that only the computer can read. 3. Computability theory. Now comes the big question. Are there problems that a computer can never solve, even with unlimited time? Yes! Some problems are just too tricky or impossible for machines. Computability theory helps us find out where the computer's limits are. A famous quote to remember, a computer is like a violin. You can imagine it making beautiful music, but it won't play it by itself. Dr. Marvin Minsky. That's why theory of computation is important. It teaches us how to write the music the computer plays. Why should you care? You might be thinking, but I just want to build games or websites. Why learn this? Great question. Here's why it matters. It helps you think like a computer. If you know what a machine can and cannot do, you'll write better code and build smarter apps. It makes you a better problem solver. You'll break big problems into small steps, just like how Google or ChatGPT solves your questions. It's the foundation of artificial intelligence, programming, and much more. In simple words, the theory of computation is like the science of thinking for computers. It's about what they can do, what they can't do, and how we can help them do things better and faster. If you're a curious student, a future coder, or just someone who loves solving puzzles, this subject will help you sharpen your brain like a sword. In our next videos, we'll go deeper into these magical ideas, including how machines read patterns, how languages are built, and how far we can push the power of computers. So if you're ready to explore the brain of the computer, hit that subscribe button and join the journey. Because when you understand how a machine thinks, you'll learn how to create the future.